Today, we're going to explore a really simple idea that actually has huge implications for, well, pretty much everything. We're talking about why some things are built to last, while others just seem designed to fail. And it's a concept that applies to everything from our phones to our study habits. So let's dive in.
It's kind of a puzzle, isn't it? I mean, you can have all the best components, and each one on its own is super reliable. But then you put them all together, and the whole system suddenly feels surprisingly fragile. So why does that happen?
Well, it all comes down to something we can call the weakest link paradox. You've heard the saying, right? A chain is only as strong as its weakest link. But here's the thing. In a system where everything is connected in one long line, every single link becomes a potential point of failure.
Okay, let's put some numbers on this to see what I mean. Imagine a system with 10 parts, all connected one after another, and each part is 99% reliable. I mean, that's pretty good, right? So you'd probably think the whole system is going to be almost perfect.
But here's the twist. The total reliability of that system, it isn't 99%. It's actually just a little over 90%. And why is that? It's because for the entire system to work, every single one of those 10 parts has to do its job perfectly. The odds of that happening get smaller and smaller with every new link you add to the chain.
And that right there is the heart of the problem. When everything depends on a single line, any one break can bring the entire system down. It's an incredibly fragile way to build things.
So if a straight line is fragile, how do we build something stronger? Well, instead of thinking about it like a chain, let's start thinking about it like weaving a rope.
This image really shows the solution perfectly. Up top, you see that fragile chain. Engineers would call that a system in series. One link breaks and the whole thing is done for. But now look at the bottom. This is a system with parts in parallel. See how at each step there are duplicates? If one path fails, the others are right there to pick up the slack. The key here is something called redundancy. We're literally building backups right into the design itself. It's a simple idea, but it totally changes how a system can handle stress and failure.
And this brings us right to our main idea, reliability design. It's all about the process of figuring out how to add these duplicates, these parallel paths, to make a system as strong as possible. But, and this is a big but, we have to do it strategically. Because in the real world, you can't just add backups forever and ever.
By creating all these different paths, you're doing more than just making something stronger. You're building a safety net. You're designing a system that actually expects failure and is ready for it.
Okay, but this is where it gets really interesting. Like I said, we can't just keep adding backups without end. Duplication isn't free. There's always a price for reliability. Every component has a cost, and every project has a budget. This is the real-world constraint that makes reliability design such a fascinating challenge. It forces us to make really smart choices. So how do you spend your limited resources? Do you add a backup for the cheapest part, or maybe for the part that's most likely to fail? This is the puzzle at the very heart of building resilient systems. It's all about making intelligent trade-offs.
See, it's not about just throwing more money or more resources at a problem. It's about thoughtful decision-making. It's about finding that perfect, elegant balance between strength and cost.
Now here's where this idea really opens up and becomes so much more. This way of thinking isn't just for engineers building computers. It's actually a super powerful tool for life.
Just think about it for a second. Backing up your final paper on Google Drive and a USB stick, that's adding a parallel path. Having a plan B for a group project in case a teammate gets sick, that's reliability design. Even scheduling rest days during finals week, that's a form of redundancy. It's a backup system for your own energy and focus. And that leads us to this really practical and honestly comforting philosophy. The goal isn't to create some perfect world where nothing ever goes wrong, because that's just impossible. The real goal is to build our projects, our teams, and even our own lives in a way that when something inevitably fails, the whole system doesn't collapse. So, I'll leave you with a gentle question to just sort of mull over. Where is there a single point of failure in your week or your studies or your big projects? And what's just one small, parallel path you could add to make the whole system you've built for yourself just a little bit stronger? Thanks so much for joining me for this explainer.